Hi ladies, this is lesson 8.6, and here we're looking at area and similarity between surface areas or areas of objects and proportions. So to start this lesson, each of these rectangles are similar rectangles and they're stretched by a factor of 2. So in the first one, the small rectangle, to get from the small to the medium-sized rectangle, we multiplied the length times 2 and the width times 2. To get from the medium to the large rectangle, again, we multiplied the length times 2 and the width times 2. But if you calculate the areas of each of these rectangles, from the small to the medium, the area is more than twice as much. So even though the length is twice as much and the width is twice as much, the actual area of the rectangle is larger than twice as much. So let's look at this first rectangle and let's calculate the area. The area of the small rectangle is 2 centimeters times 1 centimeter, which is 2 centimeters squared. The medium rectangle is 2 centimeters by 4 centimeters, which is 8 centimeters squared. And the large rectangle is 4 centimeters by 8 centimeters, which is 32 centimeters squared. So we're going to look at the relationship between the ratio of the sides compared to the ratio of the areas. So the ratio of the side lengths from the small to medium is 1 to 2. And the ratio of the area from small to medium is 2 to 8 or 1 to 4. And we can actually write these as fractions instead of how I had it written. So 1 to 2, and we said 2 to 8, which is equal to 1 to 4. Now from the medium to large rectangle, again, we multiplied each side by 2. So the side lengths are from medium to large 1 to 2, and the area is 8 to 32. So let's actually look at the side lengths, and we'll just pick one side for here, medium to large, because it'll be a little bit easier to see then. We have 2 to 4, which is 1 to 2. And then here, our area, 8 to 32, if we simplify that, that's 1 to 4. And then now if we look at the small to large, we have side length 1 and side length 4. So that's 1 to 4. And the area is 2 to 32, which is 1 to 16. So if we look at all of these ratios, the side lengths and the area lengths, to get from the side length to the area length, let's say the side length is A to B. Oops. Here we go. Okay, so to get from the side length to the area length, here's our side length ratio. To get from our side length to our area, we can square that ratio. So 1 to 2 squared is 1 squared to 2 squared, which is 1 to 4. From the medium to large, we have 1 to 2 And if we square that, we have 1 squared, which is 1, over 2 squared, which is 4. And then the small to large, 1 to 4, is our side length ratio. To get to our area ratio, we can square that. So 1 squared is 1 over 4 squared, which is 16. So the relationship between side length and area length is the ratio of side length squared. Now let's look and see that's true for rectangles. Now let's see if that also applies to triangles. So we'll just look at an example. So the area of the large triangle is 1/2 base times height. So in this example, our base is 24 and our height is 9. So the area of our large triangle is 108, and we don't have any units here, so we'll just use units squared. And the small triangle is 1/2 8 times 3, which is 12 units squared. Now let's look at the ratio of side lengths, and let's look at the ratio of area from small to large. So we can pick either the base or the height. So let's pick the height just because they're smaller numbers. So small height to large height is 3 to 9 or 1 to 3. And then the area, the small area is 12, the large area is 108, which simplifies to 1/9. So the ratio of sides is 1 to 3. And then the ratio of areas is 1 to 3 squared, which is 1 squared to 3 squared, which is 1 to 9. So that rule also applies for triangles. Now lastly, let's look at circles. So with circles, we don't have a side length. So instead we have radii, or the radius, plural. So the radius of a circle compared to the radius of the other circle. So let's first look at the area, and we're going to do this in terms of pi here. So we're going to leave pi in our answer. So area is pi r squared. So here our area is 3 times 3, which is 9 pi. So that's our area of our large circle. Now our area of the small circle is, the radius is 2. So pi times 2 squared, which is 4. So our large circle is 9 pi, our small circle is 4 pi. So now if we compare the ratio of the radii lengths, so small to large, that's 4 to 9. Oops, that's our area. We got to do the radii lengths first, which is 2 to 3. And then the area is 4 pi to 9 pi, which is the same as 4 to 9, which, if we look at the ratio of radii, which is 2 to 3, to area, which is 2 to 3 squared, which is 2 squared to 3 squared, we get 4 to 9, which is the same as in this example, our actual ratio of areas. So now we can draw a conclusion. We've looked at circles, we looked at squares, and we looked at triangles. So we're going to generalize this for all polygons and circles as a conjecture. So if corresponding side lengths of two similar polygons, they have to be similar, or the radii of two circles compare to the ratio m to n, then the areas compare to the ratio m squared to n squared, or m to n squared, which, if you remember properties of exponents from algebra, is the same thing. All right, let's look at an example here. So here we're going to look at two circles, and specifically this is talking about pizza. How much cheese would you need to cover a large 16-inch diameter pizza? All right, so let's look at our two pizzas. The first one is the smaller one that has a diameter of 12 inches. And the second one is a larger one that has a diameter of 16 inches. So we know that the ratio between radii and area is the ratio of radii squared. So here our radius is 6. Here our radius is 8. So we can say that because they're both circles, we know that the ratio of their areas compares to their radii squared. So 6 to 8, which is 3 to 4, squared, which is 9 over 16. So that's the ratio of their areas. Now we also know that in the first pizza, we needed 3 ounces of cheese to cover the first pizza. So how many ounces of cheese do we need to cover the second pizza? Well, if the ratio of their areas is 9 to 16, we can set up a proportion using ratio of areas compared to ounces of cheese. So we know that in the 9, the circle that has the 9 as the portion of the ratio for the area, we know that that takes 3 ounces, but we don't know how many ounces it takes for the larger circle, which is represented by the 16. So in order to solve this, we can cross multiply. So 9x equals 16 times 3, which is 48. Then we can divide both sides by 9 in order to solve for x. And we get x equals 5 1/3. And that's in ounces of cheese. All right, let's look at this next example. Here we know that triangle BDC is similar to triangle XYZ, which we need to know that in order to use their ratios of area and side lengths. So we're looking for this missing side length, we'll call it A. So if we know that the ratios of area is 4 to 1, so we know that the area ratio here is 4 to 1, but we don't know the sides ratio. But we do know that the sides ratio to the area ratio, so sides to area, is A over B becomes a squared over b squared. So what we need to do is work backwards. Here we have the area ratio, 4:1, and we need to work backwards to get to the sides ratio. So we need to take the square root of 4 and the square root of 1, which is equal to 2:1. So we know that the ratio here for the sides is 2:1. And we don't know what the smaller side is, but we know the larger side is 22. So 22, our ratio 22 to A is equal to the ratio 2:1. And from there, we can just cross multiply. So 22 is equal to 2A. Divide both sides by 2. And we get A is equal to 11. So then in this last example, the ratio of the areas of two similar trapezoids is 1 to 9. So again, we have areas is 1 to 9. We want to know the ratio of the lengths of their altitudes. So another corresponding part. So to go from the areas to the side lengths, we have to take the square root of 1 to the square root of 9, which is 1 to 3. So whether you know the ratio of the areas or the ratio of the side lengths, you can work forwards to find the other, or you can work backwards to find the side lengths. So please jot down any notes or questions that you have, and we can go over those next time in class when I see you. Thank you.